In section 8.1 we're going to be solving by completing the square. Before we do that, we're going to use the square root property and introduce that concept first. So on this first example, we want to get x by itself, so the first thing we're going to do is divide both sides by 2. We get x squared equals 7. To undo a square, you take the square root of both sides, and then that's going to leave you x equals plus or minus the square root of 7, which would just be 7 and square root of 7 and negative square root of 7 if you had to write them out. The next one, to undo a square, you take the square root. Whatever you do to one side, you do to the other. So then you're just going to get x plus 1 is equal to plus or minus the square root of 12. Now if I come up to the side and do factors of 12, that's 2 times 6. And then 6 is 2 times 3. So if I rewrite that, that's going to be 2 squared times 3. That's 2 squared times 3. And if I target our index, since our exponent matches our index right here, then a 2 comes out and we're left with the square root of 3 underneath. So we have x plus 1 equals plus or minus 2 square root of 3, and now we want to get x by itself, so we subtract 1 from both sides. X equals negative 1 plus or minus 2 square root of 3. If I separate it out, I get negative 1 plus 2 square root of 3, and my other one is negative 1 minus 2 square root of 3. Okay, this next page is to solve by completing the square. Basically, it's just the steps written out. If you want to take a minute, pause the computer, and then read through these steps. This will just help you if you get lost along the way. So this is kind of a resource. Okay, for the first example, first of all, it's in quadratic form. That's ax squared plus bx plus c equals 0. The first thing we want to do is move our c term over. So we have x squared plus 4x. And we're going to add 7 to both sides, so we're going to move the 7 over to the right. Now we want to complete the square, and to do that we take our b term, which is 4. You take your b term, you divide by 2, and you square it. Okay, and you're going to do that every time, so you get 4 divided by 2 is 2, and we're going to square that is 4. So to complete the square, we're going to add 4 here. If you add 4 here, you also have to add 4 to the other side. Now we want to factor this side. There's also, I'm going to do it using the rooftop method and show you. Okay, so I took a second and I did our rooftop method, and we factored this using bottoms up, and we get x plus 2 squared. There's a shortcut for this. You're going to use, it works every time for these perfect squares. You take the variable of the first term. Variable of the first term is x. Sign of the middle term is a plus. And if you take the square root of the c term, square root of 4 is 2. Square root of 4 is 2. And then you put that in parentheses and square it, you see that they match up. That's the exact same thing we got when we did the long process. 7 plus 4 is 11. Okay, now we continue from here. We take the square root of both sides, so then we get x plus 2 is equal to plus or minus the square root of 11. We get x by itself, so subtract 2. So we get x equals negative 2 plus or minus the square root of 11. If I had to break it apart, it's negative 2 plus the square root of 11, and the other one is negative 2 minus the square root of 11. Okay, the next example, the first thing we want to do is move 2x to the other side. So we get x squared minus 2x, and we want to leave our c term over there on the right. We want our constant over there so we can complete the square. We take our b term, which is negative 2, divide by 2, and square it. That gives me negative 1 squared, which is just 1. If we add 1 here, then we're going to add 1 over here. Now we're going to use our shortcut. Our shortcut to factor this is going to take the variable of the first, so that's x, sign of the middle term, that's minus, and square root of this one. The square root of 1 is just 1. Put it in parentheses and square it. Now simplify over here and you get negative 16. We continue our process and we take the square root of both sides. So then we get x minus 1 is equal to plus or minus the square root of negative 16. If I come off to the side, the square root of negative 16 can be rewritten as the square root of 16 times the square root of negative 1. This is 4 and my square root of negative 1 is I. So I'm going to get plus or minus 4i. We're solving for x. So we add 1 to both sides, and so you get x equals 1 plus or minus 4i. If you rewrite it, break them apart, you get 1 plus 4i, 1 minus 4i. Okay, our last problem, we're going to add 5x to both sides. We're going to have 2x squared plus 5x equals 12. Now before we start, we notice here that this coefficient in front of the x squared is not a 1. In all the previous problems it was a 1. So the first thing I need to do is divide everything by 2 so that I can get this to be a 1. So for first step we got to divide everything by 2. So then we have x squared plus 5 halves x equals 6. Now we will continue the process. We will take our b term, which is 5 halves, divided by 2, and then square that. 5 halves divided by 2, multiplied by the reciprocal is 1 half, so the reciprocal, so that gives me 5 times 1 is 5 fourths. These cancel down here and square that. 5 squared is 25, 4 squared is 16. So if I add 25 over 16 here, I need to add 25 over 16 here. So now we use our shortcut. We use variable of the first, so that's x. Sign of the second term, that's plus. Square root of this term, square root of 25 is 5, square root of 16 is 4. Then we're going to put it in parentheses and square it. 6 plus 25 sixteenths is 121 over 16. Now we continue, take the square root of both sides, so you're going to get x plus 5 fourths equals plus or minus. The square root of 121 is 11 and the square root of 16 is 4. So now we want to get x by itself. Subtract 5 fourths from both sides. X equals negative 5 fourths plus or minus 11 fourths. Now because I have common denominators and it can simplify, I'm going to break that down. It's going to be x equals negative 5 fourths plus 11 fourths. And then my other one's going to be x equals negative 5 fourths minus 11 fourths. We simplify that, it's going to give me 6 fourths, which is 3 halves. This is one of my solutions. And this gives me negative 16 over 4, which is negative 4. So that's for solve by completing the square.